All right, we are going to get started with the 5-2 notes. So let's just talk about quadratic functions. If I have a parabola, so here's my parabola. Let's talk about some important characteristics of a parabola. Okay, this point right here, we talked about it in the lesson 1 notes. This is called the vertex. So we're going to want to know the vertex. Another thing, and I'm drawing a dashed line right down the center of the parabola. We call this the axis of symmetry. Because a parabola is symmetrical, right? The left side and the right side are mirror images of each other. So this vertical line that goes straight down the center of the parabola is what we call the axis of symmetry. Now, we also have a way to describe a parabola as either it opens up or down. It opens up or down. This one opens up because the opening of the parabola is upward. What does it look like for it to open down? Well, an upside down parabola would be where it opens down. Okay. Let's talk about a couple other points that we've talked about before and are true about other functions, but it's good to mention it again. Wherever the graph crosses the y-axis, that is known as the y-intercept. That is known as the y-intercept. Wherever the graph crosses the x-axis, so in this case, this parabola has 2 x-intercepts. And it's possible for a parabola to have 1 x-intercept or 0 x-intercepts. All right, so let's see how we apply this to a specific example here. So identify the vertex and axis of symmetry. So A, my function is f of x equals 2 times x plus 2 squared minus 3. All right, so we are going to use transformations to identify the vertex here. So this plus 2 means that we go left 2. And this minus 3 means that I'm going down 3, which means that my vertex is negative 2, negative 3. Because I'm going to go down and to the left. Left 2 and down 2 puts me at negative 2, negative 3. So if I were to graph this, there's negative 2, negative 3, and my parabola would look something like this. All right, and this is what we did in the 5-1 homework. Now, what's our axis of symmetry? Our axis of symmetry is the vertical line that goes straight through the graph of the parabola. So my axis of symmetry is the line x equals -2. Because remember, all vertical lines, so remember hoi vux, all vertical lines have an equation of x equals -2. And it is exactly where x is -2. Now, the x value of the vertex and the axis of symmetry are going to be the same number. And that makes sense because the vertex is on the axis of symmetry. The vertex is in the middle of the parabola, just like the axis of symmetry. All right, part B. G of x equals x minus 3 squared plus 1. All right, I would like you to pause the video and try this one on your own. Find the vertex and the axis of symmetry. All right, so we're going to go right 3 and up 1. And that means our vertex is at 3, 1. And remember, our axis of symmetry has the same value as the x in the vertex. So my axis of symmetry is x equals 3. All right, sometimes equations look a little bit different than this. This is what we call vertex form, where we can just use the transformations to figure out where the vertex is. However, we have another form called standard form. And this is the form that you're going to see the majority of the time with quadratic equations. And we've already seen this a little bit with our factoring practice this week. So this is what it looks like. F of x equals ax squared plus bx plus c. Ax squared plus bx plus c. So what do each of these things tell us? Well, these different numbers will tell us different things about the vertex, about the y-intercept, about the axis of symmetry, whether it opens up or down, and that's what we're going to explore in the next example. So I'm going to start on a new page here. Example 2. Consider f of x equals x squared minus 4x plus 6. And we're going to do a bunch of things with this function. So the first thing I want to do is identify a, b, and c. So remember, our standard form is ax squared plus bx plus c. So a is the number in front of x, which in this case is 1. There's really a 1 there. B is the number in front of x, which is -4. And c is the constant on the end. So c is 6. All right. So let's talk about some things. A. Determine if the graph opens up or down. So I can know just by looking at the equation whether or not the graph opens up or down. And it has to do with the value of A. If A is positive, the parabola is going to open up. And if A is negative, the parabola is going to open down. So in this case, since A is positive, it's going to open up because A is positive. It's going to open up because A is positive. All right, B, find the vertex. All right, here's how we use the standard form to find the vertex. You ready for this? This is a formula you're going to have to remember. Vertex formula. X equals negative B over 2A. X equals negative B over 2A. So that tells me the X value of the vertex. So let's do this here. I'll stick with purple. X equals negative B. Well, B is negative 4 in this case, over 2 times A, which is 1. Negative 4 is 4. 2 times 1 is 2, which means that X is 2. Now, the vertex is a point. So I know the X value. I need to find the Y value. So I'm going to find F of 2. So I'm going to replace all my X's with 2. So I have 2 squared minus 4 times 2 plus 6, which is 4 minus 8 plus 6, which is 2. So that means my vertex is 2, 2. My vertex is 2, 2. C, find the axis of symmetry. Well, it's really easy to find the axis of symmetry if you know the vertex, because the axis of symmetry is just whatever the X value is from the vertex. So that's X equals 2. D, find the y-intercept. To find the y-intercept, you need to plug in 0 for X, aka find F of 0. Because wherever X is 0, that means we're going to be on the y-axis. So I'm going to find F of 0. So I have 0 squared minus 4 times 0 plus 6. Well, that's 0, and all I'm left with is 6. So the y-intercept is 0, 6. Lastly, we're going to sketch a graph of the function. So what do I know? I know that the vertex is at 2, 2. We found that up in part B. I also know that the parabola hits the y-axis at 6. And since parabolas are symmetrical, right, here's my axis of symmetry, I also know that there's going to be a point at 4, 6 because of the symmetry of parabolas, and that the left side and the right side are going to match each other. So that is all I need to get a really good sketch of my parabola. And it does indeed open up. So we can see the vertex, we can see the y-intercept, we can see the axis of symmetry, and you can see in this case that this is a parabola that has no x-intercepts. It does not cross the x-axis at all because its lowest point is at 2, 2. All right, we're on the new page, and obviously there's some new stuff here. If you want to pause the video to write all of that down, I would recommend doing that so that way you can listen as I'm explaining. So we're going to talk about maximum and minimum values. So minimum obviously means that it's the smallest value, okay? And maximum means that it's the largest value. So when we have a parabola that opens up, the vertex is the minimum value. It's the lowest value. So this right here is the minimum value. If it opens up, it doesn't have a maximum value because it's just going to keep going up. If a parabola opens down, then its vertex is the maximum value. It's the most. It's the highest that the parabola is going to get. Now, this is the y value, okay? We need the y value, not the x value. The other thing that we're going to bring back is the idea of domain and range. So domain in all cases for quadratic functions is all real numbers. Or we use this fancy R, or we can say negative infinity to infinity. The range, remember, is the y values or our up and down movement. So for the range is going to be either from the minimum value to infinity if it opens up, or it's going to be negative infinity to the maximum value. So let's try an example for this one here. Find the min or max. F of x equals negative 2x squared minus 4. All right, so first of all, let's figure out if this is going to open up or down. Since it has a negative a value, this is going to open down. So we are going to find the maximum point. The maximum point, the maximum value is going to be at the vertex, the y value of the vertex. So that means we have to find the vertex, okay? And remember, our vertex formula is negative b over 2a. Negative b over 2a. Now, what are a and b? Well, in this case, a is negative 2. B is actually 0 because there's no x in the middle. And C is negative 4. So when I plug this in, I'm going to have negative 0, which is still 0, over 2 times negative 2. Well, 0 over negative 4, that's okay. That equals 0. Remember, I want the y value, so I'm going to plug it in. Zero squared is 0, negative 2 times 0 is 0, so I'm left with negative 4. So the maximum value is negative 4. So if I were to graph this, it would look something like this. It would open down, and the highest that it would get to is negative 4. The other thing we're going to do is we're going to state the domain and range. Domain, like we said earlier, for all parabolas is all real numbers. Negative infinity to infinity. My range is the y values. So if I look at this little sketch that I did, I'm going to go down to negative infinity forever, but the highest I'm going to get is to negative 4. So my range is negative 4. All right, that is it for lesson 2. Make sure you check Google Classroom to see what problems you need to do out of the textbook.